Hey everyone, Nicholas here from Crippled Tech and welcome back to another video. Crippled Tech A Yokoso. Nicholas desu. I will discuss how to choose the right components for a PC build in today's video by choosing current relevant components for my mixed use case of 4K gaming, video production, streaming, photo editing, and more. I'll also do a list of components for a PC that is gaming oriented with 1440p resolution as the target resolution for gaming. So if you're looking to build your own PC or buy a custom PC build, I hope this video can help you choose the right components depending on your use case. For those of you who have more experience, feel free to add more info or correct me if you notice any mistakes in the comment section down below. Note that I'm only focusing on the PC tower, meaning I won't be talking about peripheral devices like keyboards, mice, and monitors. So keep that in mind. And I am aware that the GPU market is all over the place right now as of the time of filming this video, but the general method of choosing the components is pretty much consistent with a slight increase in performance requirements over the years. So whether or not it is worth it for you to get a GPU now, I leave that up to you to decide depending on your local market price and the time at which you're watching this video. The market may be very different than when you watch this video. So yeah, I leave that up to you. Maybe you're able to find a deal, who knows. I'll be using PCPartPicker to help list the chosen components. It is a nice website that you can use to list components, PC components that you've chosen and see the whole list along with the pricing info if the region applies to you. Link in the video description as usual. So before we get into it, there are 7 to 8 minimum required components to make up a functional PC. Now, before starting to choose your components, there are two important questions that you need to answer. First is the budget. What is the maximum amount that you're allowed to or willing to spend on your new PC? And secondly, what is the purpose of the PC? Just purely for gaming, video editing, photo editing, 3D modeling, music production, or a combination of different purposes, multi-purpose build? The answers to these two questions are essential and make a huge impact on how you choose certain components for your new PC build. So as I said earlier, I'll be choosing components based on my requirements for my mixed use case, multi-purpose build as an example, and also a purely gaming build as an example for this video. So from this video, I'll list two PC builds, one for purely gaming and one for mixed use case for my use case of 4K gaming and video production, etc. and all that. Now we have that out of the way, sasato hajimemashou ka? So let's start with the CPU first, as it decides what platform we're working with, and there are three main specs you need to look out for when choosing a CPU. The core count and thread count counts as one basically because they are tied together, the clock speed, and the socket type of the CPU. So for a CPU, the higher the amount of cores and threads it has, the higher the performance of the CPU is. And same goes for clock speed. The faster the clock speed, the higher the performance of the CPU. And for socket type, it is just to determine what platform the PC is and what chipset motherboard options are available. When choosing between Intel and AMD, because there are only these two companies that are making CPUs for the PC market, each has additional features that benefit different workloads, like AMD's X3D V-Cache that boosts gaming performance, and Intel's P-Core E-Core design on the CPUs that supposedly reduces power consumption of the CPU. supposedly. So for pure gaming, a 6-core CPU like the Ryzen 5 9600X suffices. You can even opt for the non-X variant with a slower clock speed and a generation older with the 7600X to save costs. However, I recommend 8 cores like the Ryzen 7 9800X 3D or the 7800X 3D if you have the budget to go higher, or if you're multitasking like streaming while you're playing games at the same time. Streaming games basically. Coincidentally, the 9800X 3D is currently the king of gaming CPUs, while the 7800X 3D was the model before the 9800X 3D came out. So let's add the 9800X 3D to the gaming build list. Now for my multipurpose build, since I have video production in mind and Resolve recommends CPUs with 10 to 16 cores, I'm going with the Ryzen 9 9950X with 16 cores and 32 threads. If you're budget limited, you can bump down to the 9900X 12-core processor or the last gen 7950X 16-core processor. The 9950X 3D is also available and offers both higher gaming performance and productivity performance, but at a higher cost. If your budget allows, feel free to get the X3D variant. If you're wondering why I'm not even considering Intel's offerings, the benchmark results from Hardware Unbox says it all. AMD dominates the chart in both Photoshop and Premiere Pro, while performing within a few percent of Intel's older 14th gen CPUs in Hardware Unbox 14 game average benchmark. Intel has a lot of catching up to do to compete in the high-end consumer marketplace. That is why I'm only considering AMD models at the moment. Now let's decide on the case to have an idea of how the PC is going to look roughly. This also allows us to know the form factor of the motherboard that we can go with. Note that if you need a lot of expandability and connectivity, M-ATX is the smallest recommended, as ITX form factor is extremely limited. Other than that, what case you go with is a personal preference of your PC's aesthetics and looks. You should also consider whether the case includes case fans and the airflow path of the case. Balance between aesthetics, the looks, and airflow for optimal cooling of your components, cooler compatibility, and GPU size compatibility are important as well. You don't want a case that can't fit your desired cooler or GPU. So let's get an M-ATX Montec Air 100 RGB case for the gaming build, and for my multipurpose build, I'll go with the NZXT-H6 Flow just because I like the looks of the case. Moving on to the motherboard, the specs we need to consider besides the aesthetics are the socket compatibility, the chipset, form factor, and connectivity. With both builds having an AM5 CPU, we can only look at AM5 motherboards. So the form factor determines the physical size compatibility with the case. Then we have the chipset. The chipset determines the amount of connectivity. The higher end the chipset, the more connectivity you have. The type of connectivity you get varies from board to board. So you have to look into the specs of the motherboard models to see if the connectivity, like the amount of USB ports, M.2 SSD connectors, PCIe slots, etc. Fit your requirements. So picking a motherboard is a balancing act between the price and the connectivity offered, and the aesthetic preference too, if you care about that. I'm going to select the Astro B850M Steel Legend Wi-Fi Micro ATX, which is M-ATX motherboard for the gaming build, as we have an M-ATX case, the Montec Air. And For the multi-purpose build, since I chose the NZXT H6 Flow, which is an ATX case, I'm gonna select the Gigabyte B850 Aorus Elite Wi-Fi 7 ICE for my multi-purpose build, as it offers 3 M.2 SSD slots, 1 Gen 5 and 2 Gen 4, 4 SATA connectors for additional storage whether it is SATA SSD or hard disk drives, built-in Wi-Fi and Bluetooth, and an ample amount of USB ports both on the back and internal for case connections and other accessory connections for internal components. And there's a black version of this exact board as well, and may be cheaper in your market if you don't want a white motherboard. So next, we have the CPU cooler. Note that some CPU models do come with their own stock out-of-the-box cooler, so please check your chosen CPU model, and you can choose to save costs if your CPU does have a cooler included. But just keep in mind that stock coolers often make more noise and the CPU runs slightly hotter than going with an aftermarket solution. Since both the 9800X3D and the 9950X CPU do not come with a stock cooler, I need to choose aftermarket solutions for both builds. So there are two major types of aftermarket coolers. I'm ignoring custom water loop cooling and all that. So just aftermarket CPU coolers. There are two types: air coolers and AIO liquid coolers. For ease of installation, I recommend an air cooler. Whereas if you want more features like an LCD screen for monitoring stats or displaying images, videos, GIFs to personalize your own PC, AIO liquid coolers are the ones that usually offers these features with a price premium most of the time. For my multi-purpose build, I'm going with the Corsair iQ-Link Titan 360RX LCD, a mouthful name, which is a liquid cooler with a 360mm radiator and an LCD screen on the pump block. This model is more than capable of cooling the 9950X, and it comes with an LCD screen at this price, which is unusually cheaper than most liquid coolers with a customizable LCD screen. And 3 Corsair RX 120mm fans are included for the radiator. And for the gaming PC with the 9800X3D CPU, I'm choosing an air cooler just to differentiate. The model I've chosen here is the Thermalright Peerless Assassin 120 SE, based on Gamers Nexus's review. This is one of the best CPU air coolers on the market, and at $35 USD in the US market, of course, even rivaling some liquid coolers in terms of cooling performance out there. Now we can choose the RAM. There are 3 specs you should consider when picking RAM modules: the capacity, speed and timings, and the generation. You should look at the generation first because this determines the compatibility. AM5 platform only supports DDR5 RAM, so we can only choose DDR5 RAM for both builds for this video. While AM4, if you go with AM4 platform, it only supports DDR4 RAM. With my current build here is an AM4 build, and it can only run DDR4 RAM. And as for Intel's older LGA 7800 platform, it supports both DDR4 and DDR5 RAM, but it depends on the motherboard that you get. It only supports one at a time, meaning it is not cross-compatible. And as for the RAM capacity, for current new PCs intended for pure gaming or general tasks with multitasking, 32 gigs is the minimum that I recommend. You used to be able to get by with 16 gigs as the minimum a few years ago, but now just multitasking, assuming that you have multiple browser tabs, Chrome browser tabs open, applications running at the same time for whatever you're doing, you can easily surpass the 16 gigs memory usage. So that is why I recommend 32 gigs as a minimum. With video production, streaming and photo editing in mind, 64 gigs is recommended. And as for speed and timings, AM5 Ryzen processors perform better with faster speed and lower timings. 6000 megatransfers per second speed and CL30 timing RAM is the sweet spot recommendation for any AM5 Ryzen CPUs, and going higher may increase the risk of instabilities, not to mention the cost. So for people going with AM5 processors, AM5 Ryzen processors, try to get RAM with speeds of 6000 megatransfers per second and CL30 timings. If you can't get CL30, get CL36 as a minimum. So Kingston Fury Beast RGB 64 gigs, 32 gigs times 2 DDR5, 6000 megatransfers per second CL30 RAM is the RAM kit that I will choose for the multi-purpose build. And notice the 32 gigs times 2 in brackets, meaning it is a RAM kit with 2 RAM modules, each module with 32 gigs of capacity, and combining those 2 RAM sticks you get 64 gigs of capacity total. So running 2 sticks at the right configuration enables dual channel mode, where the bandwidth is higher, allowing for faster data transfer rates, which means higher performance. For the gaming build, I'm going with the Silicon Power Value Gaming 32GB, 16 gigs times 2 DDR5, 6000 megatransfers CL30 kit for the gaming build. And going into storage in 2025, there are 3 types of storage you can consider. There's M.2 NVMe SSD, SATA SSD, and HDD, which is hard disk drive. You need at least one storage device to install your OS like Windows 11 or Linux if you prefer to run the PC. Always go for M.2 NVMe SSD for your main OS drive where your operating system is installed. The capacity depends on how much you need, so I'll let you decide that for yourself. With modern games getting so big with their install size, I'd recommend, if you only get one drive for your PC build, get at least one 2TB SSD to store both your operating system and your games, or if you prefer to split your drives, one lower capacity 512GB NVMe SSD to install your operating system, and one higher capacity, maybe 1 to 2 TB, 2 to 4 TB SSD for your games if you prefer to separate your installed programs and games. So that is up to you. And as for hard disk drives, I only recommend getting a high capacity hard disk drive like an 8 TB or 10 TB HDD as an additional storage if you need to store and archive huge amounts of data and files. For the sake of this demo, I'm choosing the Kingston KC3000 2TB, which is a Gen 4 M.2 NVMe SSD for both systems. There are PCIe Gen 5 drives out there with faster read and write speeds, of course, but the costs are too high at the moment in 2025. You most likely won't notice the speed difference between a Gen 4 and Gen 5 drives, as Gen 4 drives are already ridiculously fast enough for modern use cases in 2025. But one thing you definitely notice is your wallet being significantly lighter. So yeah, Gen 5 drives, unless, I don't know, they're currently, in 2025 at least, there are no workloads for consumers, even for video editing. You don't need the speed benefits of Gen 5 drives. Gen 4 is good enough. So save yourself some trouble, save your wallet some trouble, save your money. Go for Gen 4. Now let's move on to the graphics card or the GPU, the component that impacts gaming performance the most and graphical intensive task performance the most. So for the gaming build, it really depends on what type of games you play or plan to play. Look at benchmarks from various sources to determine which model, no matter NVIDIA or AMD, suits your gaming workloads. Looks like the AMD RX 7800 XT, which is a previous generation from the current 90 series from AMD, is the cheapest for 1440p gaming right now, recommended in early to mid 2025 actually. If you have the budget to go higher, then go ahead and get a higher performing card. If you prefer features like ray tracing and AI upscaling like DLSS or FSR in games, NVIDIA is still in the lead in this department. I'm gonna choose the RX I'm losing my voice. I'm gonna choose the RX 7800 XT for the gaming build. And as for my multi-purpose build, mixed use case build, considering that DaVinci Resolve Studio, which is my video production software, the one that I use to edit my videos and all that, prefers NVIDIA's CUDA architecture. I'm only looking at NVIDIA's options. I do hope AMD can catch up in this department someday to be more competitive. And since 16 gigs of VRAM is recommended for my video production workflow, I'm just going to choose the RTX 5080, which is plenty fast for 4K gaming and streaming, and it will be smoother experience in video production as well. Choosing the Gigabyte Gaming OC model for the RTX 5080 because it looks nice. You can just get the cheapest model of your preferred GPU if you don't care about looks. Not that you have the option to choose right now with the market situation being what it is right now, but for future references, hey, this is how it should be. Choose your GPU and look at different models and get the one that you prefer the looks of, and if you're okay with the price. So yeah. Now for the final component, which is the PSU or power supply. You should consider the wattage, the efficiency rating, and the reputation of the brand and specific model of the PSU. So for wattage, your power supply needs to be capable of delivering enough power to the rest of the components you have chosen. PCPartPicker conveniently gives you an estimated wattage requirement based on the components on the list. For my multi-purpose build, 697 watts is the estimate, so an 850 watt unit power supply would suffice, not accounting for overclocking. But I do recommend going a tier higher if you plan for future upgrades or heavy overclocking, just to have the headroom, so you don't need to change out your power supply when you do upgrade to a higher power draw component in the future. And as for efficiency rating, PSUs have an efficiency rating with the 80+ certification system, and of course avoid all models without this rating, period. No question about it, just don't. If you see a model without this without any 80+ certification, avoid it at all costs. So yeah, there's also a newer rating system called Cybernetics, but it is not widely adopted yet. Still a good to know information for you. 80+ gold is recommended. Bronze is still okay, but gold is ideal. And for reputation here is important, as you don't want this to happen to your precious PC battle station.
So I'm going to go ahead and flip this guy back on and then hit this power supply on button. Oh.
So after you've chosen a model based on the wattage and efficiency rating, look online for that specific model that you've chosen to see if there are any widespread incidents on that particular model. Avoid models that have widespread incidents, period. Then read and watch reviews of the model from reputable sources like Tech Power Up, Tom's Hardware, Gamers Nexus, and more. Another note is if the PSU includes a native 16-pin 12v2x6 connector indicated with ATX 3.1 or PCIe 5.1 certification or both. This is for NVIDIA GPUs that require the new 12v2x6 standard power connector to power the GPU. You do not need this if you're going for an AMD GPU model, but I'd recommend you to get it just in case AMD adopts the new connector in the future, or if you want to change to an NVIDIA model when you upgrade. There is also the ATX 3.0 and PCIe 5.0 standard, which is a previous rendition of the 16-pin power connector. Avoid those and get ATX 3.1 or PCIe 5.1, as the newer standard made changes to solve the melting connector issues that plagued the connector standard that started with NVIDIA's 4090s, 4080s, and now the 5090s, 5080s. So with that in mind, I'm choosing the Deepcool PX1000G for my multi-purpose build, which is a 1000 watt 80 plus gold and cybernetics platinum rated PSU. For the gaming build, a 750 watt PSU would be enough, but considering potential future upgrades, I'm gonna choose the Superpower Zillion FG 850 watt ATX 3.1 PSU with an 80 plus gold rating. There you have it, 2 PC part lists catered for different use cases, linked in the description below, so you can go in and explore what you can change to fit your needs and preferences yourself. Explore on the website freely. The website is free, of course. This is how I go about choosing PC components for a build when I part out a new PC build from scratch. There is an infinite possibility when you choose your own components and build it yourself. It is a lot of fun. Of course, not everyone is into building the PC themselves, but now at least you know roughly how to choose the right components to suit your needs if you're going with a preview or any other company that allows you to choose components and they build the PC for you. So regardless, always remember to do research and compare prices so that you can choose the right components that fit your needs at the right price. Wow, losing my voice at the end of the video. I hope you learned something valuable from this video. If you did, or if you just enjoyed the video, leave a like and subscribe to Crippled Tech for more PC tech content. And comment down any of your thoughts, corrections if you notice any mistakes, and feel free to ask questions down there as well. Always happy to help out in the PC tech community. いつでも喜んで手伝うよ。ニコラスでした。応援してくれてありがとう。これからもよろしくお願いします。じゃあぜひまた次の動画でお会いしましょう。お楽しみに。